The area of the circle below is 16 pi. It's talking about the area of the entire circle. The smallest angle in the triangle is 30 degrees, given in the diagram. Find the area of this triangle. Now you know to work at the area of a triangle, a right angle triangle like this one, you can easily do base, if you want to call that the base, you can do so, base times the height, and then divide by 2. So basically all you're doing is multiplying this side with this side, right, and then divide by 2. The trouble is, I don't know what these two sides are, right? I have no idea. But I will be able to, I should be able to find the length of this, right? And I can start off with what's given to me. The area is 16 pi. Now, area of a circle we know is pi radius squared, okay? Pi r squared. That gives you the area of a circle. So somehow, if I can work out r, the radius, this one here, if I can work out this radius, remember radius is from the center to the edge, all I've got to do is double it to get the full length, the diameter, right? And then perhaps use some trigonometry to work out the other two sides. So I can do the base times height, divide by 2 to get the area of the triangle. Okay, so I'm on a journey. To get there first, I need to say pi r squared is equal to 16 pi. Where did I get that 16 pi from? It's in the question. And where's this formula from? Well, it's the area of a circle. You can see straight away that there's pi's on both sides, so you can divide by pi to cancel them out. So these will cancel. You're left with r squared is equal to 16. Right? We know 16 is a square number, so if you square root both sides, r is equal to 4. Okay, so 4 squared means 16. So radius is definitely 4 centimeters. So that means the diameter, the full length over here, is going to be double that. It's going to be 8 centimeters. Yes. All I want to do is work out, what I'll do is, I'm going to work out the length of this. All right, that's what I'm going to do. Because I know another formula, right, that will help me to work out the area of this triangle. The other formula to work out the area of a triangle, i.e. when an angle is given to you, is, I'll just quickly show that to you here. Right, let's suppose you've got some random triangle here. Right, you've got an angle, let's call it x, and call this one, this length A, and this length over here B. The formula to work out the area of that triangle is half times A times B sine x, where x is the angle. So all I need now is to work out this length, right? To me that seems a lot less work. It saves me having to use trigonometry twice, one for this and one for the other side over here. It'll save me from doing that. If I just work out this length over here, then I can apply this formula, this other formula for area of a triangle. Right. For this, I will definitely need, I'm going to use SOHCAHTOA, because obviously it's a right angle triangle. How do I know it's a right angle triangle? Right. The reason why it's a right angle triangle is because it tells you here. Well, first of all, that's the diameter. And you've got a triangle within a semicircle, all right? And we know from circle theorem, right? If you think about circle theorem, angle in a semicircle is 90 degrees, right? I've covered this in a previous video on circle theorem. So angles in this semicircle for that triangle is 90 degrees. So we can definitely apply SOHCAHTOA because it's a 90-degree angle. So just quickly mention that. So SOHCAHTOA, which one I'll need, I don't know yet, but I'm going to find out. Right, what I need to do now is label the sides of this triangle. The longest side is hypotenuse. That's the longest side. The longest side is always opposite the right angle. That leaves me with opposite. Opposite side is always opposite the angle that I'm going to use in my calculation. And there's only one word left, adjacent. Now, out of these three, one of those I'm not going to need. Well, I definitely need hypotenuse because I'm going to use this 8 centimeters. And I'll definitely need adjacent because that's the side I want to work out. So opposite, I don't need. So which triangle, first, second, or third, has got the words hypotenuse and adjacent? Adjacent hypotenuse is this one here. So let me just do that in a bit more detail. Adjacent is the side that I'm trying to find out. Cos, C for cos, that's going to be cos 30 degrees. And this side here, the hypotenuse, the H for hypotenuse, is 8 centimeters. So all I'm going to do now on my calculator is cos 30 times 8. Cos 30 times 8. Now if you use one of those Casio calculators, don't forget to close the bracket. Alright, so if we do that on the calculator, that should give me my adjacent side. Right, I've got 6.928. I just want to preserve a couple of digits after the decimal point for accuracy. So the adjacent side here, 6.928. Now I can apply the formula. I can use the A and B any way around. I can use 6.928, this number here, and this number here, any way around. 6.928 multiplied by 8, or I could swap them around if I wanted to, times sine. Well, what's the angle between these two sides? It's obviously 30 degrees right there. So do that on the calculator and that should give me area of that triangle. On my calculator it's saying 13.856, but I notice here that's to 3 SF. So that'll be 13 point, not 8, because the next number is 5 or more, so that's going to be 13.9 centimeters squared.